Right, so welcome everyone, and let's get started with this analytical geometry. It's certainly necessary. It's a nice section in the paper. Right, I think we'll start with this one first. Question 5 in this paper. So they said that ABCD is a rhombus. They're giving you the coordinates of A and the coordinates of C. Right, so as soon as you read that it is a rhombus, you need to know what a rhombus is. In other words, the properties of a rhombus. So remember, a rhombus has equal sides. All of them are equal to each other, and the opposites are parallel. And the diagonals bisect each other. So in other words, M is the midpoint and the midpoint. Okay. And the diagonals bisect at 90 degrees. All right. So that tells you a lot, because what are we thinking about with parallel lines? We think of the same gradient. Parallel lines, same gradients. What do we know about perpendicular lines? Perpendicular lines have opposite gradients. Right. And if the diagonals bisect each other, then we have a midpoint happening. Right. So instinctively, we would want to find M. Now, that is the first question. Calculate the coordinates of M. M is the midpoint of A and C. All right. So midpoint of AC equals. Right. So we add the x's. Minus 3 plus 5, and we divide by 2. And then we add the y's and we divide by 2. Right, so what's that? 1 and 2. You can just check my algebra, okay. All right, so that is the midpoint. Then they want the gradient of BC. BC has 2 points on it, so we can use the gradient formula. So the gradient of BC is y2 minus y1 over x2 minus x1. Remember to use a bracket, 1 minus minus 4, because that will become a plus 4. 1 plus 4 is 5 over 1, which is 5. Right, so the gradient of BC is 5, which means the gradient of AD is also 5, because those two lines are parallel. Right, now the next question says determine the equation of AD. Right, and AD is this line, and we've just said that it has the same gradient as BC. So in other words, to find the equation of a line, mx plus c, I need m, my gradient, and my y-intercept c. M is AD's gradient, which is BC's gradient, which is 5. So it should flow, okay? As you see things, as you're given information, it should flow. Whatever they're telling you, they're trying to tell you other things. They're trying to imply other things. All right, so we have the gradient of this line. We also have a point on that line. So y is 8 and x is minus 3. That is minus 15, and 8 plus 15 is 23. Please just check my algebra. So y equals 5x plus 23. And you can see that even from this drawing, it's very steep. It's only going to touch the y-axis quite high up, hence the high y-intercept. Right, so that's the equation of AD. And then it says determine the size of theta, angle BAC, so this angle. And that angle is in the middle of nowhere. And remember what we said about an angle in analytical geometry. Think of tan theta equals m. Okay, but now our theta is not going to be that angle, because remember, this formula works for the angle of the horizontal. Right. Okay, so if we're trying to find that angle, it is between this line and that line, which carries on and on and on, and eventually hits the y-axis, okay? That means that I can find this angle. Oh, sorry, this is the line, my mistake. I can find this angle. Okay, that's the angle there that we want, and it is between this line, hence we can find that angle. Remember, this formula is for the angle of the x-axis. So from the x-axis up to the line, you're either finding one of those two, okay? From the x-axis up to the line is the angle of inclination. All right, so if we applied that here, that means we would need this gradient, the gradient of AC. So let's find the gradient of AC first. 8 minus minus 4 is 12. Minus 3 minus 5 is minus 8. And that simplifies to minus 3 over 2. So that's the gradient of AC. So tan alpha would equal minus 3 over 2. All right, and we don't put the negative into the calculator. We go shift tan 3 over 2 to find the reference angle. If somebody could please just tell me what that angle would be. So shift tan 3 over 2.
$56.31.
You all agree? Just check. Right, so do you see that this angle that we're trying to find is obtuse? So in other words, 56.3 is that angle. So to find that one, it is 180 minus that. Right, in other words, 123.7 degrees. So this is 123.7. And then we do the same with this one. We find that angle. In other words, we need that gradient. Now, how are we going to find that gradient? That's a bit of an issue. Or is there an easier way of finding it? We've got this gradient and this gradient, right? Okay, so then let's rather maybe we can find this angle instead of that one, because if we did that, we would need this gradient, and we don't have this gradient, right? But if we found this one, let's see if it would work. We know that that's 90. We know that, so if I've got a rhombus, the angles are also bisected, right? It was the size of theta, 6 marks, so it's a lot of marks. I'm just trying to think of an easier way to do it. That would be the obvious one, but we do not have that gradient. And we do not have that point. This angle is definitely the same, right? Because the angles of a rhombus bisect each other. Well, They are bisected. And we know this gradient, and we can find, and we've got this gradient, the gradient of AC, right? So the gradient of AC is that. So we can find this one. It's actually this angle. This is 56,3. So we don't really need that one. We actually needed this acute one. And then we can do the same here to find beta here. So not there. And then we can do angles in a triangle, because then we'll have those two. And in this triangle, we'll then have one angle left. So 180 minus those two. You see that? So let's go. Tan beta equals. So the gradient of AD was 5. It was the same as BC. And then the reference angle would be shift tan 5, right? Please just work out arc tan 5 for me. Whoever gets it first.
$78.7.
Okay, so this is 78,7. And then in this triangle, we have those two angles. So theta would equal 180 minus the sum of those two. Okay, this one was quite tricky actually. And then whatever that is, okay? You don't even have to work it out. Obviously, you just put that into the calculator. But you had to realize that the angles of a rhombus are bisected. So that is also theta. Because to find this one was impossible. You did not have the gradient of that line, okay? Certainly, that's what it works out to be 90% of the time. Wherever the angle is, you use the two lines on either side of the angle. The two sides that form the angle, those are the ones you use. But in this case, we couldn't find that gradient. So we had to look at an alternative. And that was to realize that if that is theta, that is also theta. And then we can use that triangle because we have the gradients of the two lines on either side of that angle. Right, which is the same. All right, so that one was quite difficult, and it's 6 marks, right? So that's how you need to be thinking. And you need to think of all possibilities, okay? You don't look at this and go, oh, I can't find that. Move on to the next question. You look at it carefully and you say, well, how on earth am I going to find theta? Well, theta is next to this one. How would I find this one? It's in this triangle. If I could find those two angles using tan alpha equals m, then I could find that. How can I relate those two? Oh, it's a rhombus. So the two angles are equal. All right. So you've got to sometimes think in reverse as well and be creative. All right. Any questions there?
Ma'am? Ma'am?
You can speak.
Ma'am, can you hear me?
Yes, clearly. Mm-hmm.
Okay. Ma'am, so 5.4, ma'am, if I decided to, because this is how, when I said this question, this is how I thought of approaching it. We had a rhombus, so like a rhombus, we know that we've got two sets of parallel lines. So we know that AB is parallel to BC. So then I saw that because of that, I could use like the alternate angle to say that BAC is equal to ACB. Then I get that ACB is equal to theta as well because of the alternate angle. And then afterwards, I would, because thinking of like angles of inclination, I thought of the line of AC as being inclined by theta. And because of that, I then saw that, okay, I need to find the gradient of AC, find the gradient of AC, and then I saw like it's negative, so I'll say 180 minus my reference angle to get my answer.
Hang on, I'm not with you. So you're saying you said that this angle was equal to that angle, right?
Yes, ma'am.
And then from there, where did you go from there?
From there, I would say that tan theta is equal to the gradient of AC.
No, the gradient for this formula only works for an angle off the x-axis, not in the middle of nowhere.
Oh, okay.
It doesn't work.
Okay.
Okay, so just be careful.
Okay. Yes, ma'am.
All right, okay. So remember, this formula is exclusively for an angle off the x-axis, okay?
Yes, ma'am.
Perfect.
Thank you.
Pleasure. All right, everyone okay?
Ma'am,
Yes.
if line AB was extended as you show, and you
Sorry,
had
just
the
speak a bit louder, please.
if line AB was extended
Yes.
as you and you had the coordinates of B,
Yes.
how would you then calculate theta?
So then you do tan theta equals m for this gradient and find that angle and then work in the big triangle. You'll have these two well, you would have had these two angles and then you could have worked out the third one because angles in a triangle add up to 180.
Oh, okay.
Okay, so for exactly like this, you found that. For that, you would find this, add them, and then go 180 minus the two of them.
Okay.
All right.
Thanks.
They often ask it like that. This one was just extra tricky. All right. Okay. All right. Let's have a look at this next one. Right. A circle centered at N32, so that's the center of the circle, touches the x-axis at point L. The line PQ, where's P?
It seems like I have to look at my too.
Oh, the line PQ defined by this equation is a tangent to the semicircle, to the same circle at point A. Okay, so in other words, and they didn't say that B was on the line, did they? But in any case, they're saying that there is a tangent at A to the circle, and that's its equation. It's at A, and then there's this circle around. So it's something like this, right? Okay, so something like that. Okay. Why is NL perpendicular to OL? Why is that perpendicular? A line from the center of the circle to the circumference is always perpendicular to the tangent. And they said that it touches the x-axis at L. So in other words, the x-axis is a tangent, and that's why this is 90. Okay, so using some geometry there. Determine the coordinates of L. Well, L is directly under 3, so the x-coordinate is 3. And we need to find what the y is. And they said that it's just touching. So in other words, this radius, the radius is the y part, which is 2, not so. So how could we find y? The y value here. Well, what is y here? It's on the x-axis, so it must be 0. Right? X is 3, y is 0. Radius is 2 for what it's worth. Determine the equation of the circle. All right, this is the equation of a circle where A and B are your centers. So let's see, what is our center? The center is 3, 2. So it's x minus 3 squared plus y minus 2 squared equals radius squared. So that equals 4. That's the equation of a circle. And then it says calculate the length of KL. K, where is K supposed to be? K is just in the middle of nowhere. It didn't tell you anything about K, right?
Huh?
I'm assuming that it's where this line cuts there. So KL would be the distance from there to there. I'm assuming because they're supposed to tell you and they haven't. They haven't mentioned K anywhere. And this is in a final exam. Okay, so K, I'm assuming now that it's where the line, this line cuts the x-axis, it's been y0. Right, so you're going to solve for x, take that over, and then divide by it, you'll get minus 1. In other words, the length from K to L will be 1 plus 3, which is 4. But they did not mention K anywhere, so it's very dodgy. Determine the equation of the diameter AB in the form y equals mx plus c. They did not need to say that. You can see that the diameter is a straight line. All right. And we know that this is 90 degrees, not so. Because that's a tangent to the circle. And that's the radius to the tangent, just like this was a radius to a tangent. So in other words, opposite gradients, right? This gradient is 4 over 3. M equals 4 over 3. Which means that the gradient of this line is minus 3 over 4, the opposite. So in other words, y is equal to minus 3 over 4x plus c. And then I can substitute in the point that's on the line. So 2 equals minus 3 over 4, 3 plus c. 2 plus 9 over 4. I'm bringing that over. And that is 17 over 4. Yes. Did somebody ask a question? Just please speak up, okay? Because I can't hear you. Okay, so your opposite gradient to that, the gradient was 4 over 3. This is the opposite gradient because of the 90, so it's minus 3 over 4. And then sub the point in and you find your y-intercept. Okay, so that's the equation of the diameter. And then they say, show that the coordinates of A are this. Okay, A is this point here. I just drew over it. So in other words, it's the equation, it's the point of intersection of the line, this line and that line, or this line and the circle. Easiest is to put the line equal to the line. Okay, so put minus 3 over 4x plus 17 over 4 equal to 4 over 3x plus 4 over 3. All right, so it's where the two lines cut each other. The LCD would be 12. So times by 3, times by 3, times by 4, times by 4. minus 25x equals, I took that over, and then 16 minus 51, what's that, 51 minus 11 is 40, so it's 35. So x is equal to, and you can just check my algebra please, 35 over 25 would be 7 over 5. There it is. And to find the y, you just simply substitute it back into either of the two lines, okay? So y will equal 4 over 3, x is 7 over 5, plus 4 over 3. And of course, you can use a calculator. So 28 over 15, I'm going to do an LCD, so it will be plus 20. So that's 48 over 15, which is 16 over 5. All right. And there's your y value. All right, so lots of things going on there. Lots of theory, some geometry theory as well, okay? All right, let's see, are there any questions? First of all, anything that's worrying you, rather ask so that you know, because it's these little things that creep up in every paper. No questions? Okay. All right. Okay, super. So I think that's all in this paper as far as analytical goes. So let's have a look at another one. We'll see how far we get with this one. I'm going to do this one because we won't have enough time to do everything. So let's start with this one. All right, so in the diagram below, M is the center of the circle. So immediately you know that's radius, radius. They are equal to each other. They're giving you the equation of a circle, they say. You immediately know that you can complete the square, right, to find the center. The circle passes through R and M. This angle is 90 degrees, so opposite radiant, in case you needed it. The tangent and a radius are also at 90 degrees, so also opposite radians. There we go. Show that M is the point, whatever. Okay? M is the center of the circle, so we're going to take that and complete the square. All right, so we put our x's together and then add half of that squared. Half of 6 is 3. 3 squared is 9. I take that over and I also add the 9. If I add it to one side, I add it to the other. Then plus y squared plus 2y plus half of 2 is 1, 1 squared is 1, and I add it to both sides. All right, those 3 will be a bracket squared, square root of x squared, square root of 9, that sign. If I were to multiply that out, I'll get that. Plus square root of y squared, square root of 1, that sign, and that is 18. So in other words, the center is 3 minus 1. There it is. 4 marks. Determine the equation of MR. MR, this one. Right, now you have the center, it's 3 minus 1. So you can find the gradient of MR. It is -1 plus 4, which is 3, over 3 minus 0, which is 3, so that's 1. Y is equal to mx plus c, and sub the other point in. So c is equal to -4, 1 minus 3, so y is equal to x minus 4. Right. And that's the equation of MR. And then they say, show that Q is equal to 2 minus P. So somehow you need to find some kind of an expression for your X and your Y. All right? Now, we do know, we can find this gradient, right? We can find it.
Yes, ma'am. I have a question. When we're finding the equation of the line, I wanted to ask, should the 1 be a positive or a negative, since the 2 is a positive, and isn't the half supposed to be positive?
MR is a positive gradient. It lies this way.
No, I mean the 2y. Its half is supposed to be a positive 1, and the y coordinate was supposed to be positive and not negative. Or am I mistaken?
I'm not with you. So this is 3 minus 1, right?
Yeah.
And your x is 3, and your y is -1.
Yeah.
And you
But back on top, ma'am, when we're finding the equation of the line, so we half everything and we squared it, right?
Half of 6 is 3, and 3 squared is 9. And half of 2 is 1, and 1 squared is 1.
Yeah. So I wanted to ask, why is it a positive if it's supposed to be, I mean, you wrote there as a negative. I think I'm confused. It's okay, ma'am, I'll figure it out.
It's always that sign that goes there.
Yeah.
That sign goes there. And it's the opposite. It's always the opposite.
Okay, all clear now. Thank you, ma'am.
Perfect. All right, so we need to find possibly the gradient of Mn, right? And let's see what happens, okay? So we're going to find the gradient of Mn. Let's just do it here. Of Mn. It would be Q plus 1, because it's minus 1. So Q plus 1 over P minus 3. It's going to cut out probably before we finish this, okay? Because it's on a time thing. In which case, I'll just try and finish it up next time, okay? So that's that gradient, but you know that it's the opposite gradient to that, right? Because there's a 90-degree there. And this gradient of MR was 1, so the opposite would be -1. So you're going to solve this, right? LCD, so multiply up. So Q plus 1 equals minus P plus 3. And what did they say Q equals? So let's make Q the subject. So 3 minus 1 is 2 minus P. And there we go. Q is equal to 2 minus P.
Sorry, ma'am.
Yes.
What is your reason for the gradient of Mn equaling -1?
There's a 90 here. So for 90, you always have the opposite gradients for the lines. So the opposite gradient to that, which is 1, opposite is -1. So this gradient is equal to -1. And when we work that gradient out, that's what we get.
And do you have to state a reason, or can you just plug it in?
You can just write that, but remember the formal definition is M1 times M2 equals -1. So you can just mention that.
Okay, thank you.
Okay. All right. All right, and then determine the equation of the circle having a center O and passing through N. So in other words, it's like that, right? Something like that. So in other words, we would need the radius. So what do we need for the equation of a circle? We need the center and we need the radius. We know the center, okay? So let's do that so far. X, it's minus 0 squared because it's 0, 0, right? Plus y minus 0 squared equals the radius squared, right? So x squared plus y squared equals r squared. All we need is the radius, right? How could we possibly find that radius? We know that we did work out, oh, it says here, oh, sorry, I left this out. We're not going to be able to do this without finding P and Q first. So we're going to have to think of a way of finding P and Q. It's on this line, right? It's on line MN. So we can find the equation of MN, and then we can sub this in. Right? So the equation of MN, y for MN is M, which is minus 1x plus c. And then what I'm going to do is sub in the x and y. Oh, it's going to cut out. I'm so sorry. Any second. We have this equation of this line, right? And we have a point, minus 1 and 3 on it. So sorry, minus 1 equals. So y is minus 1